All right, so additional topic number 1 is improper integrals. All right, so sometimes our limits of integration, so those a and b values, are positive or negative infinity. Okay, we call these improper integrals. You need to rewrite these integrals with limits, because we know that if we did the part where we did 1 to infinity, you can't plug in infinity, right? You always have to take the limit as a value goes to infinity. All right, so we need to somehow take care of that. All right, so on this one, I'm going to say, remember my bottom one's a and my top one's b. So I'll usually stick to that, like a is the bottom one, b is the top one. So the one that's weird is b. So I'm going to say the limit as b goes to infinity of 1 to b of 1 over x dx equals. So if I integrate 1 over x, you get natural log of the absolute value of x. So you're going to have the limit as b goes to infinity of natural log of absolute value of x going from 1 to b. So it's the limit as b goes to infinity of natural log of the absolute value of b minus natural log of 1. What happens as b goes to infinity? What's natural log of b?
0.
No.
Oh.
Natural log of b.
Wait. Natural. Oh wait, that's 1 over x then. What's the natural log of infinity?
I don't know. What is the natural log of infinity?
0. It's infinity. Well, it's smaller than
It's infinity. It's not as big as the original infinity, but it's still infinity because if you remember...
Wait, why is
There are
different
sizes of infinity?
Yes.
Shh, guys. If you remember, here's what natural log looks like. It looks like that. It goes through the point 1, 0, and it goes on forever. All right, it gets larger and larger. All right, the line y equals x looks like this. That would be the actual infinity line. If you just had limit as b goes to infinity of b, that's the line y equals x. It's lower than that line y equals x. That's what I'm saying. It doesn't go up as fast as just b, but it does still go up forever. All right.
Is that like an actual rule?
So this is divergent. So basically, all of this equals infinity. So when something equals infinity or negative infinity, we say it's divergent. It doesn't go to an actual number. It goes to positive or negative infinity. Okay, so let's try the next one. So I have 1 over u squared du. So I need to say the limit as b goes to infinity of the integral from 1 to b of 1 over u squared du. 1 over u squared is u to the negative 2. So if I'm integrating u to the negative 2, Tarek, what do I get? Negative u to the negative 1, right? So I get limit as b goes to infinity, negative u to the negative 1. Remember, you add 1 to the power, it was negative 2, so add 1 to get negative 1. I do 1 over that new power, so 1 over negative 1 is negative. From 1 to b. So I get negative 1 over u going from 1 to b. So I'm writing it that way so you guys can see when I plug in the b, it's going to be negative 1 over b minus a negative 1 over 1. Now what happens? So when I plug in infinity, saying this with quotes, we don't really plug in infinity. Yeah, the first part becomes 0, right? That goes to 0. Because it's negative 1 over a huge number. Yeah. So it equals 1. Good job, Tim Nisi. He's very excited about that. All right, so let's try number 3. Okay, number 3. So in this case, I have the limit as b goes to infinity, 0 to b, e to the negative x dx. If I integrate e to the negative x, it's kind of like a u substitution. You can think of it in your head. The u substitution would be u equals negative x. So du is negative 1 du, or negative 1 dx. Yeah.
When do you have to do computations for like rocket ships going to space? no, rocket ships going to the
Yes.
moon. You know how like we say that 1 over infinity is like negligible? Is that the same when you're talking about like going in,
Nothing is determined.
Yes, if it's infinity, it
it's
is.
still negligible.
Yes.
And at one.
Ideal.
Because you're going to infinity. But if I was doing 1 over 5 billion, that is not negligible for going to the moon. You would need to know that. All right. So here I get the limit as b goes to infinity of e to the negative x with a negative 1 out front, going from 0 to b. So think what that means. If I have a negative x for my power, that's negative 1 on top over e to the positive x, going from 0 to b. Think about it.
Why was it negative e? Oh wait, I'm right. That was the question. I'm right.
So I get limit as b goes to 0 of negative 1 over e to the b minus a negative 1 over e to the 0. Oh, that's infinity. Sorry, these are infinities. Not zeros. B to infinity.
So it's 1.
Yep, what happens? So the negative 1 over e to the b is a huge number, right? It's getting bigger every single time. So as we take the limit, it's huge on the bottom. So if I have negative 1 over a huge number, it goes to 0. So now I have negative negative, so that's plus plus. 1 over e to the 0, 1 over e to the 0 is 1 over 1, which is 1. So that's our answer. It's not always 1 for your answer. All right.
It's infinity.
So let's try the next one.
Oh.
Okay, this isn't too bad. L'Hopital's rule is like the easiest rule we ever learned. It's not bad. Integration by parts, though, it's been a little while since we had that. All right, so I'm going to do the integral from 1 to infinity. So again, my b value is infinity. So limit as b goes to infinity of 1 to b. Oops, I'm writing b, it's not writing. 1 minus x e to the negative x dx. Okay, so I need to do a u substitution. So I'm going to let u be the one that I always say vanishes. So what's the one that's going to eventually go away? 1 minus x. So dv is e to the negative x dx. So du is the derivative of negative x, so negative 1 dx. And v is integrating e to the negative x. So negative e to the negative x. So remember we have uv minus the integral of v du. That's integration by parts. So it's the main diagonal minus the bottom row. V du. Okay. So we get the limit as b goes to infinity of uv, so 1 minus x, negative e to the negative x, so put the negative out front, minus v du. So I'm going to have e to the negative x dx. So the two negatives cancel. All right, I'm going from 1 to b, and I also need these other values to go from 1 to b, so I'm going to put them there. So don't forget that. What?
Why do those go from 1 to 3?
Because we're slowly integrating this, and at the end, once we integrate it, we plug in b and then we plug in 1. Okay, so I get the limit as b goes to infinity. I'm going to bring this negative in, so it's going to be x minus 1 times e to the negative x, going from 1 to b, minus a negative e to the negative x, going from 1 to b. Okay, let's combine. So it's x minus 1. Notice how I have e to the negative x. I'm going to write that as over e to the positive x. From 1 to b. Shh, guys, I don't know why we need conversation for every little thing.
It's just so exciting. We can't
I guess.
ourselves.
All right, so e to the negative x is also 1 over e to the x. All right, we're doing the limit for all of it, so I'm going to put it all in brackets.
Wait, it's X.
Okay. So what do we see on that first bit? So when I plug the b into the x minus 1 over e to the x, what happens?
Infinity over infinity.
Yeah, you have infinity over infinity. This is where you need L'Hopital's rule.
1 over e to the x.
So we're going to use L'Hopital's rule. So just this part right here, guys, stop talking. Just this part here, we're going to plug in b. Once I take the, I can't plug in b yet. I have to do L'Hopital's rule. So I need to take the derivative of the top over the derivative of the bottom. So I get 1 over e to the x. Yes, Tarek?
If you are on the exam, for example, you have to put lahaq and that little h over the equal sign.
I would do the h over the equal sign. You don't need L'Hopot. Okay. Guys,
I don't know. I don't remember what the whole hop is.
L'Hopital's rule says that if we have infinity over infinity or 0 over 0, you can do the limit as
Just the top limit from x, y,
to any a value of f of x over g of x equals, so we always put a little h above it, the limit as x goes to a of f prime of x over g prime of x. You can just take the derivative of the top and the bottom. All right, so when we do that, we get the limit as b goes to infinity of 1 over e to the x.
Isn't it negative 1 over e?
No. Plus 1 over e to the x,
E to the x. Oh.
going from 1 to b. So I had the other part too. All right, so what do we get? So plug in b. So if we plug in b, it goes to 0, right? So I have the limit as b goes to infinity, 1 over e to the b plus 1 over e to the b, in other words, 1 over 2 e to the b, minus 1 over e to the 1 plus 1 over e to the 1. So both of these go to 0. So I have negative 1 over 2e.
Wait. What? No, it was
Negative 2 over e.
Oh yeah, negative 2 over e, thank you. So Jimmy gets the point for that one. Okay.
I have a question.
Yeah, I was just thinking that this is not what I had in the first class. So I don't remember what mistake we made on the first class. Yeah.
But if you plug in 1 for x minus 1 over e to the x, you get 0. Not the other. So which way should?
That's right.
Only
Goodness.
apply to the infinity part?
Yeah, that's true. So we do need to do one more thing here. I messed this up. Okay, so we do need to think about, if you break this up, this would be the limit as b goes to infinity of b minus 1 over e to the b minus 1 minus 1 over e to the 1. So that's for the first part. See what he's saying? So we need to do the b in 1 part. I forgot that part. Plus 1 over e to the b minus 1 over e to the 1. So this part's 0. When we did the L'Hopital part for this one, we got, for the first one, we got a limit as b goes to infinity of 1 over e to the b. Okay.
It's just negative 1 over
And then this goes to 0. So we get minus 1 over e as your answer. So this goes to 0. So you get minus 1 over e as your answer. So I should go back and look at that. Do I need to start it over?
Yeah.
Ah, guys. All right, write it in your additional notes then. We'll start from here. This is what happens when you guys just keep talking as I'm trying to do complex math in my head. Just throwing that out there.
Ow.
All right, so
We're going all the way back.
yes.
No, it begins.
So we're to this point. So we break it up. We say this is the limit as b goes to infinity of x minus 1 over e to the x going from 1 to b plus 1 over e to the x going from 1 to b. Okay, now we go ahead and plug in b and we plug in 1. So we get limit as b goes to infinity of b minus 1 over e to the b minus 1 minus 1 over e to the 1 plus 1 over e to the b minus 1 over e to the 1. So I just plugged in my limits of integration, plugged in those. This part is 0. As I go to infinity, this part's 0. So right now, I just have the limit as b goes to infinity of b minus 1 over e to the b minus 1 over e to the 1. Okay, that's just a number over there, 1 over e, right? That's just a number. But we need to consider what's happening with the b minus 1 over e to the b. Okay, that's where you need L'Hopital's rule. So it's like we have the limit as x goes to infinity, we have some kind of f of x over g of x. F of x and g of x both go to infinity. We need to figure out what the derivative of the top and the bottom is in terms of b in this case. So it ends up being, so I'll put my little h so you know you did the L'Hopital rule. So the derivative of b minus 1 is 1. The derivative of e to the b is itself e to the b. We still have our minus 1 over e, which is just a number. Plug in infinity, parentheses, not parentheses, quotes, I mean, we're not really plugging it in, but we take the limit as b goes to infinity. So we get 1 over huge number, 0, so we get negative 1 over e. And that's our answer. All right, next step. Same kind of thing. Okay, what do I need to do in order to integrate? U substitution, right? So I'm going to let u equal x plus 3. Du is going to be dx. So I have 1 over u cubed, which is the same as u to the negative 3. So we get limit as b goes to infinity, u to the negative 3 du. Now when we do use substitutions with numbers, with our limits of integration as numbers, right, a definite integral, we always have to change those to u values, right? So we need to do the same thing here. So u of 2 is really, I'm not going to put 2 here, what am I going to put? 5. And u of b, I'm going to put b plus 3. So we have that. So when I integrate, I get u to the negative 2, 1 over that new power, so negative 1/2 out front. I have my limit still. I'm going to plug in 5, b plus 3. All right, you could wait until you had x's again. You could not change those numbers, right? You could go back to x's, but I like just changing it to u. So we get the limit as b goes to infinity of negative 1 over 2u squared, going from 5 to b plus 3. So negative, when I plug in the b plus 3 in the 5, limit as b goes to infinity, negative 1 over 2 times b plus 3 squared, minus a negative 1 over 2 times 5 squared. What happens? First part? 0, right. You have negative 1 over a huge number, so it's 0. Then I have negative, negative, so plus. What's my answer? 1 over 50, right. All right, we're going to do one before we do number 6. So we'll call this, I don't know, number 5.5. So I'll do it over here. Okay, so let's do one where I have negative infinity to infinity, x e to the negative x squared dx. Okay, what's different about this one from the previous ones? Yeah, we have 2 infinities, so we need to break up the integral. So we're going to break it up. We're going to say we go from 0 to infinity, and then we go from, or not 0, yeah, we're going to go from negative infinity to 0 and then from 0 to infinity, right? 0 is a natural breaking point. So we're going to break it up. So negative infinity to 0, x e to the negative x squared. You could break it wherever you want to. 0 is usually nice, though, because it usually has nice numbers. If you use like 500, then you're probably not going to have very nice numbers along the way, right? Oh, 0 to positive infinity. All right, so the first one, this is my a value, so I'm going to say the limit as a goes to negative infinity. And I'm going to have a to 0 of x e to the negative x squared dx. Plus the next one's going to be the limit as b goes to infinity of 0 to b, x e to the negative x squared dx. It would probably be useful for us to find the integral of x e to the negative x squared dx, right? So we can kind of do this off to the side. We don't have to do it all in the problem. So we're going to say the integral of x e to the negative x squared dx. How would I find that? Do I do integration by parts, u substitution, partial fractions? U substitution, right. Nope. You don't want to do integration by parts.
Why?
Because you notice that if you let u be the power, du is negative 2x dx. That's taking care of the x, right? So it's negative 1/2 du equals x dx. That's a u. I hate when I get to the end of the page. There we go. Half du equals dx. All right, so that means that I have e to the u du with a negative 1/2 out front. So it's negative 1/2 e to the negative x squared. That's how it integrates. Okay, so going back to our problem, this means I have the limit as a goes to negative infinity of negative 1 over 2 e to the x squared, right? It's negative x squared, so I'm going to put it on the bottom, going from a to 0, plus the limit as b goes to infinity of negative 1 over 2 e to the x squared, going from 0 to b. So I get negative 1 over 2 e to the 0, right, minus a negative 1 over 2 e to the a squared. That's the first part, plus negative 1 over 2 e to the b squared minus a negative 1 over 2 e to the 0. Okay, what goes to 0? As we go to negative infinity, so think of a negative big number squared. It's a big number squared, or it's a big number, right?
Yeah.
So this is all 0. The other one is also 0. So you end up with
The other one is
negative 1/2 plus
or plus 1/2.
plus 1/2. I feel like this should be, oh,
0.
so it's 0.
How much would a problem like this be worth?
You'll be fine.
Why do we do all these steps?
Is
All
this
right.
like they put this on a free response, is this gonna be on a full choice?
This will not be on a free response.
No, it would not.
Nope.
What would this be on?
The Calc BC test.
What? Why are we doing it then?
Because I'm making you smarter. This is typical Calc 1 stuff. You guys will need to know this if you go into college.
This is making my brain hurt. I do not feel it.
All right, this next one. Guys, so if I have negative infinity to infinity of 2 minus y to the 4th dy. Okay, think about what this graph looks like. Yeah, 2 minus y to the 4th. Doesn't it look like that?
Yes.
So what could you say?
But it's why.
So that's y. That's fine. It could be any variable. I could have j there. So isn't this an even function? This is even.
Yeah.
What do we know about even functions?
We can only do half of it and then multiply by 2.
So we're going to go from 0 to infinity of 2 minus y to the 4th dy. Okay, this will make your life a lot easier on this problem because now you don't have to do a and b. You can just do b. So we're going to have 2 times the limit as b goes to infinity, 0 to b, 2 minus y to the 4th, dy,
Oh,
which is 2 times the limit as b goes to infinity, 2y minus y to the 5th over 5, 0 to b. So 2 times, ooh, tricky, tricky. Okay, all of the right side 0. What's the left side? Yeah.
So let's see. One is
Okay. Now you can think, Rachel, what were you saying? I think I heard you say it. One infinity is bigger than the other infinity.
What is that?
Guys, we talked about this for like 2 months at the beginning of the semester. Do you not remember this whole
But I
thing?
didn't understand it.
All right. What's bigger? So if I have 2b minus b to the 5th,
B to the 5th is bigger.
b to the 5th is much larger, right? So what can I do? So, yeah, ideas?
You could turn it into one fraction and use it.
You can put it into one fraction, right? Exactly. So you're going to have 2 times the limit as b goes to infinity. If I get this into one big fraction, it's like you have negative b to the 5th times 5 over 5. So plus 10b over 5. It's still not helping us too much because it's still, you're seeing a negative infinity plus an infinity, which is kind of confusing. I don't know, I think you guys should just know that this is negative infinity. I think you should know that one goes at a greater rate than the other one. Because it's just like do you remember horizontal asymptotes? This is exactly what it is. It's the shortcut method for horizontal asymptotes. You look at your largest degree.
So it's just negative infinity.
It's 2 times negative infinity, which is negative infinity. Exactly. Which makes sense if you think of the graph. If you think of the area of this graph, think about the area under this curve from negative infinity to infinity. It's a lot of negative area in quotation marks, right? Does it make sense? So this part is negative integral, this part's a positive integral. It's not as much, it's negative, therefore.
Did you do like half of these by just like looking at the graph?
Kind of, yeah. I mean, the ones that diverge, definitely.
I still do not understand the
So most of them don't diverge, though.
degrees of anything.
All right, so try the next 2. You guys should be able to do these.
Can you get this on math 9? Is infinity not plug in?
You cannot do this on Math 9 now,
Why?
because you can't plug in infinity.
They should make
There's
it
no infinity button
There
on.
should be.
No.
Texas Instruments has failed me.
All right, so number 7 should be 1 over 18, and number 8 is negative 1/2. So, Evan, you had a question?
Never mind, it just.
You found it. Okay. Okay, does this make sense?
Yes.
Okay. Your homework's pretty easy. I think most people in the first class finish it before they even left the room. So.